Assalamualaikum warahmatullahi wabarakatuh to Dr. Isha and hi everyone. My name is Muhammad Najmi bin Muhammad Nizam. I was a group leader to BMFI-35 Smaseh and our title NINS project is about IoT integrated safety helmet for oil and gas industry. So today we want to present video presentation for our project. So this is our team's member. First is Nur Hasha Fariha binti Zakaria. Second is Muhammad Amin bin Muhammad Zulkifli. And third is Nur Syafini Masyarah binti Norman. Fourth is Muhammad Najmi bin Muhammad Nizam. This is me. And our last team member is Ko Jin Jian.
So this is our CAD model. In this slide, the CAD model is viewed in isometric view. So as you can see, there are four main components in this drawing, which will not including adjustable knob and also chin strap. So in next slide, I will explain in detail each of the feature of the safety helmet. So this is the lamp and it is located at the right side of the helmet. So for this lamp, we opted it to be a small lamp and adjustable and also easy to be removed. So when maintenance is needed, we do not have to do the whole maintenance. We just have to maintain the lamp part. So the maximum of the weight of the lamp is 60 gram. We choose the lighter lamp so that it will not affect the total weight of the helmet itself. Next, as you can see, is a camera and it is located at the front of the helmet. We choose a smaller size of camera with weight of maximum 80 gram. So the camera then will capture the view of the user and others also can view it through any application. This camera will operate along with IoT system. Not only that, this camera also will help the communication system of the user and others, even if the user is located far away from the others. This is our IoT system. IoT system is located under the left side of the helmet brim. This IoT system will be connected with camera and also microphone so that any communication can be made through the IoT system. We opted the sound when communication to be produced is at least 30 decibel so that the others can view the sound clearly through the application. The next feature is air ventilation system. So as you can see, there is a small hole on the left and the right side of the helmet that will allow air to flow through it. This also will help the user, especially in hot weather, as it will help to reduce the heat in the helmet itself, so that they will not experience any heat stroke. So the last feature is chin strap and adjustable knob. Noted that this is not in the CAD model. This chin strap and adjustable knob are located inside of the helmet. The adjustable knob will help to adjust the size of the helmet so that it will fit the user head fittedly. The chin strap will also help the helmet to stay still on the user head as it locks the helmet with the user head. If look at the slide, there is also a headband. The headband is made from a sweatproof material so that the user will be comfortable to use it during a hot weather and also when they produce too much sweat. Next in the slide is our product specification and bill of material. Our safety helmet is made from ABS material as it offers a good tensile strength, impact resistant, heat resistant, and also high surface hardness. The diameter of the shell of the helmet is 27.5 centimeter and its height of the shell is 14 centimeter. So the brim size is 8 centimeter. The size of our safety helmet is similar to other safety helmet in the market because we outsource the helmet itself. Our safety helmet offers 5 features, which is chin strap, adjustable knob, lightweight communication system, and also a lamp. So on the right side is bill of material. There are total of 9 material is needed to produce this helmet. All of the parts are needed in one unit except for the wire, which is needed in 1.5 meter.
Assalamualaikum and hi everyone. My name is Muhammad Najmi bin Muhammad Nizam. I want to continue our slide is about engineering analysis. So in this topic, we use comparison test for our project. So comparison testing is a mechanical test used to determine the behavior of materials under comprehensive loads. It helps measure the strength, stiffness, and deformation characteristic of a material when subjected to the compression force. Compression tests are commonly performed on various materials such as metals, plastic, concrete, and composites. The compression test involves applying the comprehensive force to a specimen until it fails or undergoes a predetermined deformation. The test specimen is usually cylindrical in shape and it is placed between two plates of a testing machine. The force is applied uniformly and axially to the specimen, causing it to deform in the axial directions. During the test, the applied force and the corresponding deformation of the specimen are recorded. This data is used to generate a stress-strain curve, which depicts the relationship between the applied stress force divided by cross-sectional area and the resulting strain change in the length divided by the original length of the specimens. The stress-strain curve provides valuable information about the material behavior, including its elastic range, yield strength, ultimate strength, and modulus of elasticity. So this is a picture compression test at material testing at lab FKP. So this is a bending deformation analysis. This is our project before compression test. Shape plate before thickness 120 millimeters, width 180 millimeter, and height is 120 millimeter. So next is after compression test in our project. So shape plate after thickness 120 millimeters and width 180 millimeter and the height is 100 millimeters.
Assalamualaikum and hi. My name is Aminin. I will share about the strain stress test result that we got from the compression test that we did at the material testing lab at the FKP. This is the result. There are a few important information that we have to take note and jot down from the test result data. Firstly is the shape. Shape is plate. Then we got the data of the maximum force, maximum displacement, maximum stress, and maximum strain. And this is the graph for force versus the stroke. Next, we go to the strain stress analysis. For the strain analysis, since the helmet is symmetric, the strain distribution will also be symmetric. At the midpoint, the strain is maximum and equal to the calculated value of approximately 19.1725%. The strain gradually decreases towards the end of the beam or the helmet, reaching zero at the peak supports. When we saw the graph will show a parabolic shape with the maximum strain occurring at the midpoint, tapering to the ends. The strain analysis reveals how the deformation is distributed at the helmet under the bending load. The maximum strain occurs at the midpoint, indicating the region of the highest deformation. This information is crucial for assessing the structural integrity and designing the helmet to withstand the applied load within the acceptable strain limits. Next, for the stress analysis, based on the compression test data, the maximum stress analysis shows the number that is 0.24450 Newton millimeter square. This is important to see how the internal forces are distributed within the column under the applied compressive load. The uniform stress distribution indicates the column is experiencing an even distribution of compression across its cross-section. This analysis is crucial for assessing the structural integrity and designing the helmet to withstand the applied load within the acceptable stress limit. For the conclusion of strain-stress analysis, overall, based on the data and the analysis above, we can say that the helmet is quite durable. It can withstand force up to 5.28125 kN. We can also conclude that the material used for the helmet is high quality and good material. After we observe the patterns in the strain-stress distribution, by identifying areas of high or low values, there is no need for the improvement and restructure on the helmet design. Now we go to the safety factor calculation result. Here the formula for the safety factor: load that breaks the product over the normal load on the product, where for this project, the load that breaks the product is the maximum force that we got from the data test, that is 5.28125 kilonewton, and for the normal load on the product is maximum force human head can exert, which I got this value from the dash. And for the calculation, we got the answer is 2.296. And for the conclusion on the safety factor analysis, the specific value of an excellent safety factor can vary depending on the industry, application, and level of risk associated with the component or structure. Generally, a safety factor greater than 2 is often considered good, but for the critical or high application, a safety factor of 3 or more may be desired. Based on the calculation, we note that the result we get is 2.269, which is the safety helmet result is quite good, but not excellent enough. It's important to note that achieving the excellent safety factor may come with additional costs, such as increase the material requirement, more conservative design, or added weight. Therefore, the desired safety factor should be balanced with other design considerations, including cost, weight, limitation, and performance requirements. Ultimately, the determination of an excellent safety factor should be based on true risk assessment, engineering judgment, and consideration of industry standards and the best practices. That's all.
Hi, Assalamualaikum. My name is Smaseh. So here I am. Would like to explain about the cost analysis on our product, which is a safety helmet with IoT. Basically, cost analysis on safety helmet with IoT involve assessing many expenses according to the design, development, and manufacturing of the equipment. So to know the cost associated with our product, we did cost analysis to evaluate potential goods and profit it offers. As we can see from the slide, there is 3 important costs in getting cost analysis. So we have raw material cost, fixed cost, and variable cost. In the next slide, we will show about the details analysis on these 3 costs. The first one, we list all the components for raw materials with its quantity and cost. In designing safety helmet with IoT, we have adjustable knob, sweat-proof headband, IoT, lamp, camera, chin strap, sponge, wire, and of course a helmet. The total cost of raw material is RM138. The second is fixed costs, which not affected by the amount of products, such as factory rent, equipment, and supervisor salary, and the total fixed cost is RM 350. Lastly, we have variable costs, which is will always change, like material, overhead, and labor per unit, and it costs RM 150. Let's move to the next slide for break-even analysis, which to know how many sales required to pay back the operating expenses and the final profit. First, we have break-even by 30% profit per unit. So to get the profit, we use raw material cost multiply with profit percentage, and we got RM 41 and 40 cents. Meanwhile, for selling price, we use raw material cost plus profit per unit just now, and we got RM 179 and 40 cents. After that, we calculate total cost at break-even point of 10 units estimate sales. We use fixed cost plus the summation of variable cost per unit multiplied by sale volume or unit, which is 10, and we got RM 1,850. Since we are required to conduct analysis and evaluate the profit of estimate 30 unit sales, we also need to calculate the total cost of estimate 30 unit sales. After that, by using total revenue, which is RM 5,382 minus total break-even cost RM 4,850, we got RM 532 profit if 30 units sold.
Hi, I'm Ko Jing Xian. Now I will present about the sustainability in this project. So we will talk about the design for environment, how we are going to decide the 5 cycles that involved in this chapter. First cycle is about material extraction. We choose ABS material for our product. So ABS is a lightweight material and it can help to reduce the fuel consumption during transportation since it is lightweight. So it is also recyclable. It can help to reduce the amount of plastic waste sent to the landfills and conserve resources by introducing the material into the production cycle. The next stage is production. ABS has relatively low melting point, which means that the lower the processing temperature is needed. And since it's lower temperature, so the energy consumption is low compared to other plastic, and it reduces the needs for additional protective coatings as well. And lastly, it optimizes the production process and energy consumption. The third cycle is about the transportation, distribution, and packaging. The transportation is preferred the van than compared to the lorry, and our product is also suitable to transport by van because it needs to reduce the energy, the fuel consumption, the carbon emissions from the transportation side. So next is the exclusive distribution is preferable because with the retailers involved, that we can reduce the transportation and logistic complexity as well. So at the same time, it's also help to lower the greenhouse gas emission as well, the lower the fuel consumption. So, okay. The fourth stage is about the usage or user. And since ABS is a very high durable material, so it contributes to the longevity of the product and reducing the need for frequent replacement, and thereby reducing overall waste generation. The last is about the end of life. The outer straw may be placed in the standard plastic recycling bin, and the EPS form may be crushed and used as packing material or soil softener. So it can be reused, recycled as well. So that's all. Thank you.